Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. This episode, I went deep with Hamilton Ulmer. Hamilton's currently working at the intersection of UI, exploratory data analysis, and SQL at MotherDuck, and he's built a long career in EDA. Hamilton's also a bit of a polymath. I started out our conversation talking about his musical career, which you can totally find on Spotify. Then we dive deep into the history of exploratory data analysis, from Tufty to Tableau to Vega Lite to WASM. Honestly, I don't go super deep on data viz, so I learned a ton from Hamilton. Even if you spend most of your time below the front-end layer of the stack, it is super interesting and important to understand the trends in both the practice of data viz and the technologies that underlie that practice. All of it deeply shapes the space that we operate in. Without further ado, let's get into it. Hamilton, welcome to the Analytics Engineering Podcast.
Oh, thanks for having me.
I think this is going to be fun. In researching you before the episode, I came across the part of your LinkedIn that talks about you as a musician, which is not a thing that many people's LinkedIn profiles have. And in fact, I went to Spotify and looked up you under your artist name, Make Under, and you've got a few things up there, and took a listen. You have a very dynamic singing voice. Your composition is very unusual. I listened to these songs and I actually didn't know how to say oh, this is very similar to this. It was very unique.
Yeah. So a bit of background about that part of my life. My parents were both visual artists. My dad was a sculptor. My mom was a painter. I thought that my niche in my family was music because nobody had really fully claimed it. And when I was 12, I heard, I had this sort of awakening when we saw an orchestra play Stravinsky's Firebird Suite. And I thought at 12, that's the thing. That's the thing I'm going to do with the rest of my life. And then I basically threw myself into music at that point and just sort of lived and breathed it. I went to a kind of tiny arts magnet school and kind of figured I would be a composer. And then when it came time,
what does that mean? Did you play an instrument? Did you play
Yes.
5 instruments?
Yeah, it's more like you play 5, more like you play a lot of instruments kind of well than play one instrument very well at all.
Okay.
You learn enough, I think, just to get good at writing for those instruments, typically.
What were your favorite?
Definitely piano, singing, and horns. I think horns are so beautiful. It's I think there's something really singerly about a horn section doing something really cool. I didn't know what I didn't know at that point, though, so I didn't understand what it actually meant to, in practice, be a composer. So when it came time to apply for college, I just applied to a bunch of universities and then decided to explore other things basically after that, and did something totally different, studying statistics in undergrad and grad school. And then right after that, decided to go right into the music industry instead. And I did that for about 12 years.
I found that to be a very questionable decision. You presumably paid a lot of money for your undergrad, and then you immediately picked it up and you went straight into the music industry, right?
Well, it's kind of, in a way, yeah, it's kind of working out in the end, I think. But I remember reading something that I think Jeff Bezos said, where he didn't want to be in his late 80s and regret doing something earlier in life, a sort of regret minimization. And I thought, I'm so passionate about this thing, I need to give it an honest try. And so I spent 12 years doing that. And Make Under was sort of my pet project for my music, but I used that also to get other gigs in industry, especially production and arranging gigs. And so that for me was one of the big, it's sort of, I saw Make Under as my sort of portfolio of interesting sounds I can give your music. And so I did some of that work for a while, and then met someone, thought about whether what I needed to do to start a family, and realized I wanted to stay in the Bay Area, not move to LA or Nashville. And so pieces sort of fell into place that I moved kind of full-time into tech, which I'd always kept a part-time tech job most of my career just to pay the bills. And yeah, so I did that in 2018, and here I am.
But you were at Mozilla for much of the the time that you were doing music, right? You had kind of dual track.
Yeah, so as soon as I graduated from college, I got a job at Mozilla. This is right before data science was a term that everyone knew about. And I had a background in statistics, and I was really good at statistical analysis and things like that. And within a couple months of working there, I told them, like, I'm going to quit and just join the music industry, and it's going to work out great for me. Then my then boss, who I think was much older than me and much smarter, said, that sounds great, but why don't you work half-time here and we'll give you benefits as well? And I said, okay, I'll do that for a while, but I probably won't need it. And I did that for basically maybe 8 or 9 years, and then moved to full-time in 2018. And it was that, I think that's financial security that enabled me to do interesting things with music, because I no longer had to like hustle really hard and work gigs I didn't want to work. I could do what I want to do. And so that's why Make Under sounds the way that it does. There's no financial pressure to make it work.
I don't know all of the things that you got into at Mozilla, but if you're similar to other folks who started their data science careers in the 2010 era, you probably ended up getting stuck doing all different parts of the analysis pipeline. And over time, it seems like you and your career have become more focused on the data viz part. Is that fair to say?
Yeah, I think that's fair. So when I joined Mozilla, we had, I think, what was then considered pretty big data. And it was also very complicated, messy stuff that the browser was generating. And we were using a lot of that telemetry to also basically calculate the numbers for the business as well. And data visualization for me has always been a means to an end. And that means is understanding the data that powers the business and the product. And so I think those interests are kind of intrinsically connected. A lot of data visualization and exploratory data analysis does focus a lot on the sort of end of the analysis pipeline, the presentation layer, things like that, things that you might put in a slide deck. But having to work with extremely messy, highly nested data generated by the web browser that was very popular, which, possibly runs in a semi-degraded state, like not all the data that it sends is good data. That first mile is actually way more interesting to me. And actually, it's maybe the genesis of my interest in data tools in general is that first mile problem, not the last mile problem. And I think this is a place where exploratory data analysis is like especially valuable. But I think the way that people think about EDA is more in the middle or toward the end. But that first part is actually really critical.
That's so interesting.
So that's been my focus basically ever since.
Okay, great. I had thought that we were going to take the conversation in a certain direction, and now I'm updating my priors. It's so interesting, though, that EDA, you're right, I typically think about this being done by a business analyst that's looking for an insight to drive the business forwards. But exploratory data analysis is also used to answer the question, can I trust this data? What do I need to do to it to get it to a state where I can trust it and kind of almost like feel it in my gut a little bit, so I know what I can expect from it?
Absolutely. I think this is the fundamental trade-off in a lot of analytics tools. The people that make those tools or made this, the libraries that we use are often made by technical people, oftentimes people with a research background that have to do data cleaning. But the financial value comes from the end user experience of dashboards, basically, right? Charts that like people that need to make business decisions, what they actually consume. And so there's always been this trade-off actually with EDA tools between these two things. And I actually think like that the case of Polaris, which is a research project out of Stanford in the early 2000s, these researchers wanted to kind of figure out how to make EDA interactive and exploratory. And this was in an era when, computers were really just starting to become good at this kind of stuff and data was beginning to be generated. And those researchers, the Polaris paper was groundbreaking for analytics and HCI. Those researchers went on to found Tableau. They thought Tableau, obviously everyone kind of knows Tableau as a BI tool, really popular BI tool.
Wait, is it that Tableau was informed by this paper, or is it literally like the people who wrote this paper became the founders of Tableau?
They founded Tableau. So they took the ideas of Polaris and built a company off of it. And the killer use case, though, wasn't the first mile. It was the last mile, actually, because the economic buyer of the tool cared a lot about understanding what was going on with their business. So a lot of the focus for EDA tools has been on BI rather than the thing that actually, I think, really vexes data practitioners, which is cleaning the data, right? Everyone likes to joke that 80% of the job is cleaning the data. So if you look at like a homunculus model of data work, it's largely about trying to correct problems with data collection as early as possible to figure out what you can possibly say about the business down the line. So for me, that's the rich area. But there's, we're at this paradox, right? That's kind of a high value thing, but there's hard to sell that, I think, to people. And that's why I think BI tools focus on the presentation layer.
So, okay, I want to get there. But before talking about the business model for the like very interesting research area of data viz, there was what's his name? Jeffrey Here. He has this massive PowerPoint presentation that I think he did for some capstone project somewhere. You linked this to me, and reading through this, I mean, it's like very extensive. But the thing that I found the most interesting was that I had been aware of some of these different technologies in the space. So you've got your whole tidyverse ecosystem. You've got, gosh, what was the one that we used to use? High charts, and of course D3, and there's all these different. But this slide put all these different ideas and technologies on almost like a lineage tree that showed how one led to the next to the next. Because most of them are not commercial products; they're like libraries that get built into commercial products. Can you talk a little bit about how over the last 20 or so years, like the industry has evolved? Like, are we operating at a higher level of abstraction than we used to be?
So I'll go a little bit before 20 years and then get to the last 20 years period. So computers, amazing thing. Imagine it's the 1970s and you're a statistician doing research, and you discover that you can put your tables of data into the computer to aggregate and visualize it really fast. Something that was not before. You had to kind of do it by hand. If you've ever read anything by Edward Tufte with like kind of historical data viz, you could tell somebody like had a pencil and paper and had to calculate where to put the points to show the aggregation, right? Really time intensive. So John Tukey was this really famous statistician. He's actually the person who invented the term exploratory data analysis. And the basic premise of it was...
What's the era here?
This is the 70s, 1970s.
70s,
yes.
Okay.
And so he said something that is not controversial, which is maybe you should look at the data before running a statistical analysis, which was not really possible, I think, in an easy way without computers to make that happen. And there's some really groovy videos on YouTube worth looking up of him demoing some of the first data visualization software. I think it was SLAC, the Stanford Linear Accelerator, and it's like super retro graphics, but pretty groundbreaking for the 70s. So he kind of basically, it was part of a movement to bring computation to statistics that became kind of the whole point of the field after a certain point. And then in the early 90s, you had spreadsheet software essentially being the most important data tool ever created was your Excel. At that point, Lotus, 1, 2, 3, they began adding charts to their spreadsheets. And that was really a great early form of data visualization, probably the most popular form, right? Business and user use cases, perfect for them. Then you had Tableau, as we just discussed, kind of how Polaris led to Tableau. And that was a revolutionary idea that really...
And when was that? We're talking early 2000s at this point, right?
Early 2000s, right.
Yeah.
Just at the beginning of like the big internet boom, where internet companies became a bigger deal, web applications became a big deal, the browser became a big deal. So you have this other cross current here where the browser became the medium for interactive data visualization, and not some desktop app that a bunch of people have to write C++ code or whatever to like make your charts. That, I think, was probably the biggest expansion of the labor market in data visualization, and that's where you see D3 becoming kind of the one of the most important entry points for those people to become essentially front-end engineers. You also had the tech boom, which, yeah.
And was D3... The person who originally authored D3 was at the New York Times, right?
Well, he was actually a researcher, Mike Bostock.
Oh.
And in fact, actually, you mentioned Jeff here. He was also one of the authors of the paper. I believe maybe Mike was Jeff's grad student. And Jeff here is very
Got
famous
it.
in the data viz world, has made a lot of contributions to the field. But D3 was the premise of D3 at that point, was that building high level primitives for data visualization wasn't possible without getting the sort of mid level connection to the browser APIs. And that was really the key to the lock, I think, for everyone. And now D3 is still widely used. It's not used in the same way as it was in the past, but it's still very widely used. I use it every day for all of the data visualization tooling I build, just because it has so many helpful things that I don't want to build myself at this point. So the web became important for the medium of data visualization. And really for like analytics tools as well became very popular, right? Most of the BI tools moved to being kind of web-based in some way. And so then you had this other cross current in the last 20 years, which is the tech boom, the internet companies, things like that. You had a huge influx of technical PhDs into industry, which had kind of happened before in the tech industry, prior to this, but kind of in an unprecedented rate. You had all of these people bringing their analysis tools that they used in their research. So this is when Python became kind of a big deal. The scientific Python computing stack was something that you might have kind of toyed with in grad school or used for your research, and now you're bringing it to your job because it's like the tool you know. R is another example of this. This is sort of where I enter the story, actually, is as a statistician with R.
So I'm so glad that we got here in this branch of the conversation, because this has always been something that's bugged me. In like circa 2015, I was becoming familiar with the Python and R part of the ecosystem, but was coming from the more BI part of the ecosystem. And as you said, BI became more web oriented in around this time. And so I was really used to interactivity in my charts at this point. You would click on a series and that series would be highlighted or whatever. And these pieces of interactivity were actually quite important to me. And then but of course, the BI ecosystem does not do whisker plots very well, et cetera, et cetera. Like all of the like more scientific types of plots. I mean, most BI tools don't even do, what is it called when you faceting. So then I learned the R and Python ecosystem, and it felt like stepping back in time a decade. Everything was just printing images to my screen. I'm like, hey folks, like what's going on here? Did these two unify? Did R and Python ever get the interactivity, and did the libraries for the web ever get the kind of scientific functionality?
This is such an interesting point you're making, because I think this is actually sort of the like endpoint of the narrative, is what you're talking about. And I think you hit the nail on the head. When I joined industry, this was 2010, pretty early on. I knew D3 and I knew R and Python, but I also knew that the primary way in which I did data analysis was at that time Jupyter notebooks, and or the R console. And these are great environments for doing statistics and data analysis, but you're missing something, I think, fundamental that you had gotten with Tableau. One of the things that made Tableau so great was the interactivity and the fact that everything was purely visual. You didn't have to write the query to do the thing with the viz. You can just sort of drag and drop things. And that was amazing. But that was in the end business user world, which I think that the people that were building out this sort of new code-based data analysis stuff, they weren't business users in the past. They were scientists.
They didn't feel that lack.
They didn't feel that lack. And also, I think there's a thesis here, right? Which is the fact that JavaScript was not sufficiently advanced enough to do what Python did is the reason why these new EDA tools lacked in the kind of end user visualization layer. Really great libraries for visualizing data like ggplot in R and matplotlib in Python. But yeah, they're designed for a different world without the web. And that's always been a challenge. I think we're seeing a new crop of tools that understand this, and people building this type of scientific computing software, they learn JavaScript and TypeScript now. They don't just know Python. And so they are building new types of tools that are incredibly interactive.
That's cool. I did not know that.
Yeah, I think we're seeing a lot more of this trend now, in part because the data transformation layer is now also being done with tools like DuckDB, which is a whole area and topic of conversation, I think, for exploratory data analysis, and possibly the key that unlocks a lot of what you're talking about.
Let's start to move in that direction, because we do want to get to DuckDB. Maybe to round out the kind of historical perspective here, I remember I was working at a BI company called RJ Metrics in 2013 to 2016, and we used high charts. And then I remember talking to one of the co-founders of Mode, Josh, in I think it was 2017, and he was like, "Look, we're using this thing called Vega Lite. It's awesome." But like, what if somebody were to go out and build an application that required some visualization capabilities today, what libraries would they be looking to
I think
use?
you just said it. Vega Lite has been I think it's been the bridge. I think there are a few different ones now. Vega Lite was probably the first to really bridge the gap between like the scientists and the front end BI people. This is why you see Vega Lite used extensively in products like Hex, as an example, which I think Hex is doing a
Got
great
it.
job of figuring out how to straddle the line between like the data scientists and the business users. I don't know if you just saw, we're recording this on November 1st. They just launched Explore, which I think is a huge thesis about how you bridge the gap between these things, and very exciting, powered in part by Vega Lite. And so I think that's been the answer for quite a while. You also have Observable. I'm not sure if you're familiar with the product Observable. It's founded. It was a company founded by Mike Bostock, who made D3, and it's a pure web-based
Yes.
JavaScript visualization notebook environment, kind of best of D3 and a lot of the best of the web. His company built an additional kind of library that's very similar to Vega, like called Observable Plot, which also bridges this gap. And the cool thing about these libraries is you can use them in Jupyter notebooks. You can use them in your web applications when you're building your BI tool, things like that. So there are some things that I think connect the two together.
These are fundamentally JavaScript libraries, right?
Yes. So that's, I think, the interesting thing. These are libraries that visualize data that you aggregate in some other way outside of JavaScript, and then you feed in those aggregations into these tools.
Because you can do some math in JavaScript, but that's like not a good way to do that.
You can do a lot of math in JavaScript. The problem is, it's not so much. I mean, JavaScript is like relatively fast, but it's more that the kind of aggregations you need to do to enable interactive visualization, ones that enable filtering and zooming and things like that, can't be done at the JavaScript layer. You have to go back to the database and do something interesting there to actually make the visualization kind of update. And that's the huge problem. There's a gap, right? It's front end has been all the focus, and then there's a back end that is sort of removed.
I hopefully queued you up perfectly, because today you work at a little database company called MotherDuck, who, among other things, is very involved in the roadmap for DuckDB. And at the outset, MotherDuck, I think, is still a pretty early stage company. Full disclosure, I'm an investor, but doesn't have infinity human resources to throw around. And so here you are, someone who really cares a lot about data visualization. You're not, I don't think, working on the DuckDB optimizer. I don't think you're working on the support for multi-class. Like, my guess is there's a specific bet here about how DuckDB is relevant in data viz in a way that like maybe not all databases are.
I think that's definitely true. How much do your listeners, would you say, know about DuckDB?
My guess is that probably everybody listening here is familiar with the name DuckDB, but you should probably do a little bit of an overview.
So DuckDB is an in-process database. Probably the closest analogy would be something like SQLite, which I don't think is a fair comparison because DuckDB does so much more. SQLite is this tiny transactional database that is arguably the most important piece of software ever made. I don't think that's actually probably a stretch to say that. All our lives are powered by thousands of SQLite databases on all of our devices. Our browsers all have individual SQLite databases powering them. It's an incredible thing when you can just have your database as a file somewhere, and then whatever process can just query that directly, rather than having a database run on its own independent server. And so DuckDB is kind of like that. But for analytical queries, not transactional ones, the kinds of queries that like your audience probably is quite familiar with. The project started, I think, in the late 2010s. Hannes Moeleisen and Mark Roosevelt were two researchers at this research institution in Amsterdam called CWI. Previously was probably best known for being the place where Python was invented.
Oh, really? That's funny.
Funny coincidence. Maybe not a coincidence. But the influence for DuckDB actually was the workloads that PhD data scientists were bringing to industry.
Hmm.
Crunching down CSV files and Parquet files has always been a bit of a challenge. And Mark and Hannes realized they could build a kind of purpose-designed database to make data analysis easier. And so that was sort of the genesis of DuckDB. But as they began working on it and applying some of the most cutting-edge ideas in analytical databases to the project, they began to realize it could do more and more stuff. And that's kind of why I joined MotherDuck, was because I'm part of this movement of people that care about data viz that have discovered DuckDB and like really can't look back anymore. That divide we were talking about, the front end being all JavaScript and the back end being who knows what. If you can make that back end DuckDB and you can do incredible things with it, you can actually determine the queries you need to run on the front end and effortlessly update your UIs. And so it reduces the latency of interactions for really complex things. Then there are other currents as well.
Okay, wait.
Yeah, I'll pause there.
That's the UI interaction paradigm that DuckDB enables is a big topic. But for a second, we talked about the difference between the BI world and the kind of scientific computing world before. One of the interesting differences there is that scientific computing does not typically speak SQL. It has the concept of a data frame, and data frames can be kind of translated into the idea of a table, but oftentimes you can operate on data frames in ways that a SQL database, at least most SQL databases, cannot. Yet it really seems like DuckDB also came out of that world. Maybe this is less true today, but if I, in 2015, was talking to somebody that was using Python and I suggested maybe they should just spin up a Postgres database and like store all their data in it and write SQL queries against that, they would have like looked down their nose at me. What culturally has changed? Is DuckDB capable of doing some of these scientific computing functions, or does it not need to? What's changed?
Well, a couple of things, I think. One, I think in 2015, the people that would scoff at the idea of writing SQL, maybe they adopted BigQuery and discovered writing SQL actually wasn't so bad. I think a lot of people that didn't know SQL learned SQL to do their jobs in industry. So that's changed. SQL, there was a period, especially in the 2010s, where people weren't sure if SQL was going to survive.
Yeah, that's true.
And so I think the environment was different then. But one thing that ended up happening was more stuff moved to SQL, actually, rather than less stuff moving to SQL. And I cited BigQuery. I was at Mozilla when we bought BigQuery, basically, and having done data analysis with Hive and other kind of MapReduce style things in the past, it was like a breath of fresh air, right? Being able to write SQL, a query that I could analytically kind of verify myself and just have it do the thing was really special. So I do think that industry has moved more towards SQL. That said, data frames are ergonomically like quite amazing, and especially ours ecosystem with dplyr for data transformation is like a really elegant, nice way to work with data. I think we're seeing two things. One, databases like DuckDB, actually, you can do things in dplyr and it will write the DuckDB query for you, which is really nice. So you don't have to necessarily know DuckDB to use DuckDB's execution engine, which is like really the magical thing about it, I think, is that it's so fast.
I really desperately love dplyr. It is like maybe my favorite of all our packages. I feel like sometimes there's this religious war between SQL people and not SQL people. And the more nuanced and I think more correct perspective is that I think that having a declarative language that is mathematically provable to determine data manipulations is incredibly useful. And yet authoring SQL by hand as the most ergonomic way to express something may or may not be true in a given circumstance. dplyr is extremely ergonomic, but fundamentally backed up by SQL.
Yeah. And also, I think what's interesting about this too is a lot of these analytical SQL dialects are starting to also address some of these same types of problems. I think I mentioned BigQuery before, like writing BigQuery SQL and working with arrays in BigQuery and things like that, it became easier to do some of those hard data manipulation things in SQL. And looking at DuckDB, I think something that Mark and Hannes care a lot about is just the ergonomics of writing SQL. So they've made their own extensions to SQL to make it easier to do the sorts of things that you would see in in dplyr or pandas. And also, I think SQL is complicated because it's kind of an ancient. At this point, I could call it an ancient programming language that has stood the test of time. It's not Latin; it's something else, right? The spec for SQL is like thousands of pages, and there's not a single database on the planet that actually implements all of the spec. It's one of these bizarre situations we're in where the dialects differ actually in some critical ways, but if you kind of know one SQL, if you know like one dialect of German, you could speak the other one kind of with other people. It's similar with SQL. So this sort of kind of lack of control over the language itself does two things. One, it frustrates everyone because it's much easier to go to R or Python where everything is well defined and the grammar is small. You don't have to implement. There's not thousands and thousands of keywords to implement in these languages. But also, it's an area of innovation and opportunity for other database engines. And I think the DuckDB creators have seen that. And so things like list comprehensions, which are so useful in Python, you can actually do them in DuckDB SQL. Function chaining, you can also do that in DuckDB Python or DuckDB SQL. And it's really nice, actually. It's a nice SQL to work.
That's so interesting. I did not know that. Function chaining is like one of the most ergonomic things about working in R or Python to do data analysis. So that is super cool.
Yeah. It's an interesting area of innovation. And I think it also upsets a number of people as well. There are people who think like SQL needs to be kind of this boring thing that everyone knows and stop innovating. I'm much more of a sort of experimentalist. So given that like there is no actual SQL standard beyond the bare minimum that everyone implements, why not innovate? I think it's great.
The interesting interaction paradigms that are possible with DuckDB that are not really possible, I think, with other database engines. And I think the core of this is that DuckDB does not need to be run on a server. Most databases, there is a very clear client-server paradigm, and on your local machine, if you're going to be developing in that database, on your local machine, you have like a Postgres client or something. And the thing that's responsible for is connecting to the remote server, and then you exchange data over the network. And inevitably, that is going to be slower than if the data is stored locally. I mean, there's a reason why people love Excel. I mean, there's this nice UI paradigm, but also for modest data sets, it's freaking instantaneous. Can you talk a little bit about how is it possible that DuckDB runs locally? Like, why can't I run Snowflake locally?
To understand this, you have to understand a bit of the historical trends in the tech industry around the concept of big data. So 15 years ago, plus or minus however many years, tech companies began generating large amounts of data as they had users use their applications. Facebook's a great example, right? The amount of data that needed to be processed in order for you to understand it was much larger than what one computer on its own could even do. You could like go buy a desktop tower, put it on your desk, get all the data on it and attempt to do something with it, but it was going to be extremely slow, right? And the disk space wasn't big enough. You didn't have enough memory to do interesting things, and the software just wasn't really there. And so this is when we begin to see...
and you would actually hit error messages where like out of memory exceptions would show up in Excel or other applications in like unpleasant ways.
Yeah, computers weren't good enough. Basically, yeah. Computers have recently become good enough, I think, and that's kind of the TLDR. But because they weren't good enough at that period, we began to see great research out of Google around MapReduce and about splitting up computation across a bunch of essentially rented out computers in the cloud, a bunch of cheap, low-powered machines, and this sort of fanning out the computation to a bunch of machines that weren't on your computer was sort of the way that you could actually do anything meaningful. And that idea took hold in industry as more companies became data-driven. This was sort of like the way to do it. And this is actually part of the core thesis of MotherDuck, which is it's 2024 now, and I'm using a MacBook Pro, a modern MacBook Pro. And when I switched from SQLite to DuckDB, querying a really large, 10 gigabyte data set felt like that. It was like instantaneous. And the first time that I ran a query in DuckDB, I thought, is it broken? I don't think this is possible. And then as I began to sort of understand more, and as I learned about Jordan Tigani, the CEO of MotherDuck, his core thesis, it's that our computers have actually gotten fast enough to handle those workloads that back in 2011, we could not have done on a desktop tower. And that's really magical. Computers have gotten good enough to do what was previously considered very big data, or big data, I will just say. And the definition of big data has sort of shifted over time to be increasingly larger. And so the things that were big data when Snowflake and BigQuery were created might not necessarily be big data today. They might be something that you could process on one really beefy computer that you rent from AWS. And so I think that's why DuckDB is becoming really popular, by the way, is because computers have caught up.
There is an architecture, the MPP, massively parallel processing architecture, that became, I think, initially popular in the 2000s with kind of on-prem, like the data warehouse appliances. And then I think that you could reasonably say that Snowflake and BigQuery are also versions of an MPP architecture. It certainly evolved from the earlier versions, but there's probably some overhead involved in this MPP architecture overall. Like, you've got all these different nodes, you're trying to coordinate the behaviors of the different nodes. It's actually very challenging to make sure that all the nodes have the right data sets and they're reporting back consistent results, blah, blah, blah. But then all of a sudden you say, okay, I'm going to kind of get rid of all that overhead. I'm going to create a really tight analytical database that still has columnar data, blah, blah, blah. But that all of a sudden can be faster, and it can also be distributed to your local machine. Am I getting that right?
That's right. I think that is probably the most concise story for DuckDB and why it's so successful. And the fact that it can run in a process anywhere means it's running everywhere. Like, companies are adopting DuckDB as point solutions all over the place. And you don't hear about it all the time, but it is absolutely happening. So it may not be like the total solution for their data today, but it's oftentimes the best solution for individual pieces. I think I saw somebody joke that DuckDB may single-handedly prevent global warming caused by the JVM.
Okay. That's an interesting thesis. We're 40 minutes in, and we're still doing rundowns on the history of different parts of the technology stack. But I think it's so important because this whole set of things only makes sense when you understand where it all came from. Can you explain one more piece of technology for us? WASM.
Sure. So WebAssembly, this is something that's very near and dear to my heart. I worked at Mozilla for quite a while, as I described earlier. One of the projects that I started with some colleagues in 2017 was sort of a radical idea. It was in 2017 at least, radical. It was a pure browser-based scientific computing environment, one that didn't require a Jupyter kernel or a server or anything else. You just download the web page, and you can do things in it. And we thought, this is going to be kind of cool. Let's see where this goes. Working at Mozilla.
Wait, are you serious? Mozilla is the original authors behind WASM? I didn't know that.
Mozilla was one of the core contributors, and the person who created Emscripten and was one of the kind of creators of WASM, Alon Zakai, was at Mozilla at this time.
That's so interesting. For some reason, I thought that WASM was directly related to Figma. I thought that Figma had played a big part. Maybe they just figured out how to use it.
Yes, I think Figma was an early innovator in the WebAssembly space.
Got it.
So this is 2017. Nothing like this had really existed before. The person that created WebAssembly had a few years before shown just the most unhinged demo, which was the game Unreal Tournament running in the browser, and nobody had ever seen anything like that. We thought oh, wow, the browser is the modern web, kind of the modern communication medium of the future. It can do all of these things, and now it can start to run things that you can only run on your desktop. That's because browsers are getting better, computers are getting better. And so we actually, Alon was just working at Mozilla, so we just thought, let's just put a meeting on his calendar and talk about WebAssembly. At the time, what we wanted to do was that other thing that you had mentioned, Python was not built for the web, JS was built for the web. Can we actually make a scientific computing environment in JavaScript that felt as good as it felt to use R? R is such an ergonomic, wonderful language for what it does. And so we met with him because we wanted to compile all these linear algebra libraries and figure out basically how to replicate R in JavaScript. And he said, that's interesting. Why don't you just bring all of the scientific computing stack in Python to WebAssembly? And that way people don't have to learn JavaScript. And we thought, that'll never work. At this point, my colleague, Mike Drottboom, who had just joined, he's probably best known as one of the maintainers of Matplotlib before he was at Mozilla. He came back 2 weeks later and showed us Pyodide, which was the whole stack running in the browser. And so Iodide eventually died, and Pyodide has gone on to have its own kind of wonderful life. And so the premise of WebAssembly is to take software that runs only on your desktop that you usually have to compile from C or C++, and creates a special binary that a browser can actually run. And that's really cool in a lot of ways. And Pyodide is a great example of that as a Python runtime that has Matplotlib and Pandas and NumPy, all those great pieces running in the browser.
And I think that DuckDB also can be run in WASM, right?
That's right. So using Mscripton, which is the library that Alon Zakai made, that's the one that powers Pyodide. It also powers DuckDB WASM. And Mscripton gives you all of the kind of API endpoints and build system to compile your C++ code to run in WebAssembly. And so DuckDB WASM is a fully functioning database running in your browser. And it's only really possible because DuckDB itself is a really small binary, and you can actually download it into your browser and begin running queries right there. And of course, it's not as powerful as running it on your computer because WebAssembly has a ton of limitations. It's single-threaded. It's like one crappy CPU or one crappy thread versus, your computer may have 16 or 32 really nice threads.
So you might not want to run 10 gigabytes of data through it, but it's still very, very good for what, 100 megs, 200 megs?
We're finding the upper boundaries, but definitely I think a couple hundred megs works really well with it. And maybe more to the point, we're talking about the magic of reducing the latency of doing something in a graph and then seeing everything update. And DuckDB WASM is part of that story. And this is sort of where MotherDuck's big bet is. Now, MotherDuck, kind of from a product perspective, is an extension in DuckDB. That's how you essentially interact with MotherDuck in code. And so we can use the MotherDuck extension in DuckDB WASM and then use DuckDB WASM as this powerful caching layer for queries that are run remotely. And by having this dual execution model, we can actually do some really incredible things. We can use the locality of DuckDB WASM to reduce the latency of interactions. And we can use the big beefy server on MotherDuck to do heavy duty computations. And those two play really nicely together. I think this sort of architecture is the future of interactive EDA. It's such a nice experience when you see it in action.
It was always very easy for me as an analytics consultant back in the late 20-teens to propose an architecture. You're just like, stick all your data in X database, and I'm very confident that it can scale to really any arbitrary needs that you would have. And it's just like very easy to think about. I think, as you said, it is kind of hard to understand the advantage of what I think is a more complex architecture until you actually use it. And when you use it and see videos of it, it is pretty stunning. But I think you would agree that, like one of the things that MotherDuck has to contend with that I think Snowflake doesn't really need to think about, or BigQuery or anybody, is like a complex caching dance. Like what data should be where to maximize the interactivity component. Is that fair?
I think it's fair, but I think in practice, more workflows and data are like the one that MotherDuck uses than not. And think about like the human's computer as an important part of the architecture, the actual de facto architecture. I'll give you an example from my time as a data scientist. Like we use BigQuery. Often I would pull down a sample of a table and do stuff with it in a Jupyter notebook first. Like iterating on things locally is so much faster. And while everything you said is true, it's kind of a simple story from an architectural point of view. From a workflow point of view, it's kind of miserable. Like you want to work really quickly. You want to reduce that feedback loop to doing something, trying out the transformation and seeing if it was successful. That human in the loop part is so painful with anything that isn't local that I think this MotherDuck architecture is actually quite nice for those people. A good example of this is DBT DuckDB, right? Actually running DBT locally on your computer actually reduces a lot of the feedback loop, and you can, essentially investigate different parts of the process really easily with a local DuckDB database. before whatever, shipping it up to MotherDuck or wherever you're using the data, the end database. That local story it's always going to be part of people's workflows. So the question is whether or not we force them to figure it out themselves or whether or not we build it into this architecture.
These are interesting ideas, but help me pull this forwards. Where the usual way that we end one of these episodes is me asking you where do you hope that the data industry is going from here? But I want to give us like plenty of time to explore that, because I really feel like the trends that you're talking about are all kind of coming together now, and they really have the potential to pretty significantly change the way that data is done over the coming 5 years. Is that fair?
I think that's very fair. Imagine all the things that we just said about what it was like to do this stuff in 2012 versus 2024 with a modern MacBook. Computation is going to continue to get cheaper and better. Computers are going to continue to get better. And the definition of what is actually big data, something that requires a distributed system, that bar is going to move up higher and higher. And I don't think that if you take our CEO's core thesis, which is most people don't have big data, the people that do have big data don't actually scan all of the big data at once. They scan a small data's worth, so on and so forth. That's going to continue to be true because I think the business case for data is not changing as rapidly as our capacity. So if all of that's true, then all of the technology that we've started using a decade ago, begins to look kind of more and more inefficient and less cost effective. And ultimately, I think in the case of data warehouses, if there's a data warehouse that is cheaper, more ergonomic, and basically is easier to onboard into, it doesn't actually require you to worry about whether or not your data is big or not. I think they're going to end up buying that over existing solutions. That's, of course, a business thesis that we have at MotherDuck. And we do see some customers actually describing some of the things I just said. It's like the feedback we get, easy to use, probably going to cost us a lot less than your competitors. Something has to change there. And I think there's just a simple technological advantage to basically being on the forefront of small data, because the definition of small data is just changing. The goalposts keep moving every single year. Bigger data is becoming smaller and smaller. So I think that's still the most exciting thing.
If you leave out the database side of it, and that's important, but I think that from an EDA perspective, I think you would imagine that DuckDB is going to enable more. I mean, we were talking about Hex before. Hex uses DuckDB to power the Explorer interface that they launched recently. I would be shocked if in the next 5 years we were not using DuckDB as a part of our infrastructure in some way, shape, or form. I think it is going to kind of reshape a lot of the data ecosystem in kind of unexpected ways. Absolutely.
So specifically for EDA and both the first mile problem we described earlier and the last mile problem that I think Hex's Explorer covers, the reality is I think BI tools, data analysis tools are all swarming to DuckDB. I think it's in 5 years, it's going to be the database that everyone uses for these sorts of things. And simply because it's just too easy to build good tools with it. And that's why I fell in love with it. It made my life substantially easier as a tool maker. And everyone I know that is in this space also feels similarly as well. And so what I think that means, especially with something like DuckDB WASM in the browser, is that this local computation layer as more and more people cache data locally, these types of interactions that we're describing become richer and more interesting. This really interesting project, actually by Jeff here and Dominic Moritz, both of whom were responsible for Vega Lite. Mosaic is this really cool library that essentially you define your data visualizations, and then under the hood, it rewrites the database queries to give you highly optimized data cubes that power the visualization. And that enables you to do interactive scrubbing and zooming. And because it's doing just your almost basic data cubing, all the interactions are instantaneous. It's 60 queries a second to update the entire visualization.
Well, that is really something. 60 queries a second is not a throughput that many database platforms would be excited, analytical database platforms would be excited about.
I feel like I buried the lead. This is for a lot of EDA tools why DuckDB is actually so exciting, is because when you reduce the latency of querying for data visualization down to sub-second, sub-100 seconds, whole new classes of interaction are then possible And so whole new types of data tools are actually made possible. And I think that is why everyone that builds data viz tools is swarming to DuckDB.
Hell yeah. Hamilton, this has been a lot of fun. Thank you for joining.
Yeah, thank you for having me.
The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.